Today I'm gonna talk about differentiating sums and differences. Before I solve the following examples, I would like to list all the formulas that can be used for solving these problems. We have 5 formulas here. Let's take a look. For the first formula and the second one, these two are for the exponent. Okay, for example, here x to the power negative n equals 1 over a to the power n, and nth root of a equals a to the power 1 over n. And for the third, fourth, and fifth ones, they are from the derivative. The third one is constant rule. Okay, constant rule. The derivative of a constant equals 0. And the fourth one is power rule. Okay, the derivative of x to the power n equals n times x to the power n minus 1. And the fifth one is about constant multiple property. Okay, so k times fx prime equals k times fx prime. Okay, we only do the derivative for the function. Okay, for the function if we have multiplication with a constant. Now let's take a look the first example. The first example is about to evaluate h9 prime. How to evaluate h9 prime? There are actually two steps. First of all, we're gonna evaluate the derivative of hx. Then we're gonna plug in 9 for this derivative. Okay, so let's take a look. We follow the first step. Hx, derivative of hx gonna be 2fx plus 5gx plus 8. Okay, 8. So here we have 3 terms. We can follow the sums rule. Okay, sums rule. So we do the derivative for these 3 terms gonna to do the derivative for each term. Okay, so we have 2fx prime plus 5gx prime 8 prime. Okay, and for the first term we're gonna use rule number 5. Okay, constant multiple property. So we're gonna do that, keep the constant the same, and do the derivative only for the function. And then similarly for the second term, we have 5 times gx prime, and the third term we're gonna apply the constant rule, right? The derivative of a constant equals 0. Okay, so basically we're gonna get 2fx prime 5gx prime. Now we're gonna follow the second step, plug in 9. We have okay, plug in the 9, and we know the f9 prime equals 2, so we plug in 2, and g9 prime is 4. Okay, plug in, and it will boil down to 4, 20, 24. Okay. Now let's take a look the second example. For the second example, we find x to the power 3 in the denominator. We don't like the exponent x to the power 3 or exponential function or polynomial function in the denominator. We want to convert it. Okay, we want to convert it. So how to convert it? We're going to use the formula here. We're going to use the reversal process of this formula. Here, a to the power n corresponds x cubed. Okay, and then we can convert it to the a to the power negative n. So here we can convert this guy, right? Convert this guy to the x to the power negative 3. Okay, to the power negative 3. Actually, for easiness to understand, I can write down it like that. Okay, write down it like that. 1 over x to the power 3. Okay, 1 over x power 3 should be following this rule or reversal process. We're gonna get x to the power negative 3. Okay, so let's take a look. This guy can be written down as 7 over 4 times x to the power negative 3. Okay, negative 3. Now we can use the power rule to evaluate the derivative. And here we're going to apply the rule number 5, constant multiple property. So we have 7 over 4 and do the derivative for the function x to the power negative 3. And we have what? Using the power rule here. So n is negative 3, x to the power negative 3 minus 1. And here we can simplify it. Is 7 times negative 3 would be negative 21, 4. And here is x to the power negative 4. Okay, again, we can use the rule number 1. Okay, here is x to the power negative 4. Here is a to the power negative n. So we can write this guy in the denominator. Okay, in the denominator. So we can write down this guy in the denominator, and the exponent gonna be positive instead of negative. Okay, positive 4. Okay, now let's take a look the third one. Okay, we're gonna follow very similar strategy. Here we find the x squared in the denominator, so we're gonna use the reversal process of formula 1. Okay, so here we can write down as (2 over 9 x squared minus 7 over 5 and times x to the power a to the power negative n. So here x to the power negative 2, right? And then we can apply the sums rule. Okay, apply the sums rule. And for this guy, we can write it down as 2 parts, right? 2 parts. One is the 2 over 9 x squared subtract 7 over 5 x to the power negative 2 prime. Okay, so for each term we're gonna use the constant multiple property. Okay, we have x squared prime and 7 over 5 x to the power negative 2. Okay, now we have what? For the first term, we can get 2x using the power rule here. And for the second term, we have negative 2 x to the power negative 2 minus 1. Okay, minus 1. And of course, here we can write down as 2 minus 1. Okay, and 2 times 2 gonna be 4. Okay, 9. And the exponent 2 minus 1 is x. And here, negative, negative, positive. Okay, 7 times 2 is 14, is 5. And here is x to the power negative 3. Again, for the last term, we can use the rule number 1. Okay, rule number 1. And we can write this guy in the denominator. So we have 4 over 9x plus 14 over 5 times x to the power 3, or x cubed. Okay, now let's take a look. Another 3 examples. Okay, 3 examples. Let's take a look at the first one. For the first one, we have 2 terms, and the first term is very clearly we can apply the rule number 1, and for the second term we can apply the rule number 2. So we can write down GW 7 over 5 and W to the power 6. Follow this rule, reversal process, right? So we have W to the power negative 6. Okay, and this guy, fourth root of W, gonna be W to the power 1 over n, 1 over 4. Now we can do the derivative. Okay, we can do the derivative for these 2 terms. And we do the derivative for these 2 terms. We're gonna do the derivative for each term, following the sum rule. Okay. And then we're gonna apply the rule number 5, constant multiple property. Keep the constant the same, and do the derivative for the function. Constant multiple property. Okay, now we're gonna apply the power rule. And for the second term, we have 1/4, 1/4 to the power 1/4 minus 1. And then we can simplify it. That will be negative 42 over 5 times W to the power negative 7. Here is cancel out, or we can have 1/2. Okay, that should be to the power negative 3 over 4. Okay, negative 3 over 4. And then we can tell here we have a negative exponent. Negative exponent. That means we can apply the rule number 1 again. So we can write down this guy is W to the power 7. Okay, W to the power 7. Put this guy in the denominator, and then we're gonna change the exponent to the positive. Similar, we can put this guy in the denominator and change the exponent to the positive. Okay, change the sign to the opposite. Now let's take a look the second one. And for the second one, we can follow the formula 2 firstly. Okay, so we have negative 11, and the square root of x can be written as 1/2, x to the power 1/2. And now x to the power 1/2 can be written as following the rule number 1. Right? Here in the denominator, x to the power 1/2, that means we have x to the power negative 1/2. Okay, negative 1/2. Now we can apply the power rule. Okay, or the constant multiple rule. Okay, and we have constant negative 11, and do the derivative only for the function. Okay, and we can simplify it. That is power rule, and for these two terms, negative negative positive 11/2, and for this term will be negative 3/2. And again, we can use the rule number 1, and we have 11/2 x to the power 3/2. So we put this guy in the denominator and change the sign to opposite. Change the sign to the opposite. Okay, here's negative, here should be positive. Now, let's take a look at the last term. Again, we're gonna use the rule number 2. Okay, so we have the rule number 2. We have square root of x should be x to the power 1/2. Okay, and then we can use the rule number 1. X to the power 1/2 is a reversal process, right? So we put this one as x to the power negative 1/2. Okay, negative 1/2. And then we do the derivative for each term. We can write down as 0.8 x to the power negative 1/2, and 3.3 x to the power negative 2 prime plus 7x prime. Okay, and again we can apply the constant multiple property, right? We keep the constant the same. Okay, and do the derivative for the functions. And here do the derivative for the x. Okay, now we can apply the power rule. So 0.8, that should be a negative 1/2, negative 1/2 minus 1. Here 3.3 times negative 2, x to the power negative 2 minus 1. And for the derivative of x should be 1. Okay, so that is a well-known formula. Okay, derivative of x should be equal to 1. Okay, so here we directly apply this rule. Okay, and we have 7 times 1. Okay, 0.8 times negative 1/2 should be negative. Okay, so 0.8 divided by 2 should be negative 0.4, and here should be negative 1/2, negative 1, negative 3/2, and here's negative negative is positive. 3.3 times 2, 6.6. X to the power negative 3. And the last one is 7. And again, we can see here we have negative exponent. That means we can put in the denominator. Just change the sign of the exponent. Okay. Put in the exponent 3 over 2 and plus 6.6 x to the power 3 or x cubed plus 7. Okay, that's it.